Hello everyone, today our topic shall be KOHLRAUSCH'S law from electrochemistry. Today we shall learn how to find molar conductivity at infinite dilution. So our first question today shall be, calculate the molar conductivity at infinite dilution of AgCl from the given data. So they are asking you to find molar conductivity of AgCl. Your molar conductivity of AgNO3 is 13.34 Siemens meter square per mole. Molar conductivity of KNO3 is 14.49 and molar conductivity of KCl is 14.99. So we shall find the molar conductivity of AgCl from these three given. So these are our given. So we are supposed to find molar conductivity. This represents molar's conductivity of AgCl. This represents molar conductivity at infinite dilution. So AgCl, AgNO3 is given, KNO3 is given, and KCl is given. So this is how we are supposed to write. So the first thing we need to know is, how can I get the molar conductivity of AgCl from this given data? So look this given data carefully and see where we have Ag. So out here we have Ag. Since we are finding Ag and out here we have Ag, so I'll write this one first. AgNO3. And now Cl. Where do we have Cl? So out here KCl, we have Cl. So I'll add both of these. So now after adding 2, I can have Ag and Cl. Since we are finding AgCl, I will have Ag and Cl. But we are also going to have KNO3. We don't need this KNO3, right? So out here we are going to subtract this one. So minus KNO3. So now from these two, when I add them together, I'll be having AgCl as well as KNO3. I'll be having AgCl as well as KNO3. Since we don't need KNO3, so I'm subtracting this KNO3 out here. So from here one KNO3 will come, and from this KNO3 both of them will subtract together, and only we shall have Ag. Right, this one first, and then again go for Cl. So where do we have Cl? Out here. So both of them I will add together, and after adding these two I will have AgCl as well as KNO3. Since we don't need KNO3, so I'm subtracting this KNO3 out here. So now I shall write down the values. 13.34 plus 14.99 minus 14.49. So if I add this one, I shall have 13.84 Siemens meter square per mole. So this is our first answer. It is very easy, the problem. So since we are supposed to find molar conductivity of AgCl, so AgNO3 plus KCl minus KNO3. So you'll write down the numbers, add them, subtract, and you'll get the answer. I hope you understand numericals. So now we shall solve our next problem. The molar conductivity at infinite dilution for HCl, KCl and CH2Cl COOK are 4.26 into 10 to the power minus 2, 1.50 into 10 to the power minus 2 and 1.13 into 10 to the power minus 2 Siemens meter square per mole respectively. Calculate the molar conductivity at infinite dilution for CH2Cl COOH. So I'll write down the givens. So here is our given. So your molar conductivity of HCl is 4.26 into 10 to the power minus 2, KCl is 1.50 and CH2Cl COK is 1.13. So we're going to find for CH2Cl COOH. So now again we'll look out here. CH2Cl COOH. CH2Cl COOH. Where do we have this one? CH2Cl COOK. This is K, but this is H. But all this part is similar out here. CH2COOH. So first I will write down this one. CH2Cl COOK. We don't need K, we need H. So from where can we get H? We can get H from HCl. Out here there is H. So I'll add these two together. So HCl. Now when we add these two together, I will have CH2Cl COOH. And what will be left? KCl. Since we don't need KCl, so I will subtract this KCl out here. Minus KCl. So since we need CH2Cl COOH, so I add these two together. So H will come here, K will go here. So KCl. Since we don't need KCl, I'm subtracting KCl out here, this KCl. So now you can write down the values again. So in simple way, if you want to know, just remember you're going to add two electrolytes and you're going to subtract one. In simple way, if you want to know, just remember you're going to add two things together and remove. So this will be our answer. 3.89 into 10 to the power minus 2 Siemens meter square per mole. Always remember, you're going to add two out here and subtract 1. So let's go to our next question out here. The molar conductivities at infinite dilution for NaI, CH3COONa and CH3COO2 Mgr 12.69, 9.10 and 18.78 Siemens meter square per mole respectively at 25 degrees Celsius. What is the molar conductivity of Mgi2 at infinite dilution? So now first of all, I will write down the given again. So here is our given. Molar conductivity of NaI is 12.69, CH3CONa, sodium acetate is 9.10, and CH3CO2 Mg is 18.78. We're going to calculate for Mgi2. So now look this one carefully. Where do we have Mg out here? So out here we have Mg. So I'll write this one first again. So we have Mg out here, but we don't need this part out here. And now what about I? Where do we have I? We have out here NaI. This is I2 and this is only I. Out here we have only one I, and out here we have I2. So in order to make this one 2, what shall we do? We shall multiply with 2. So I multiply with 2 in order to get I2. Since this is I2 and this is only one I out here, I need to multiply with 2 in order to get I2. So now if you add these two together, I'm going to get, this part is just a rough sheet. If I add these two together, I will get Mg I2, and also I will get this and this 2Na, and then I will have CH3COO2. If I add these two together, I will have CH3COONa. Since this is 2 and this is also 2, I will write here 2. So from after adding these two together, I'm going to get Mgi2 as well as 2CH3COONa. Why? Because there is 2Na out here and CH3CO2 out here. So if I add these two together, since both of them are 2, so I'll write 2 at the beginning. I'll have CH3COONa. Since we don't need this one out here, so I'm going to subtract this one. Out here we have this one, right? CH3COONa, but we have only one out here. I multiply with 2. So now this and this will cancel together, and then what will be left? Only this one. I hope you understand. Out here we have only one Mg, so I didn't put 2 out here because Mg is already 1 out here. But in spite of that, we have acetate out here too. and also we have I2 out here, and we have only I out here. So in order to make this one I2, I multiply with 2 out here. So our main question is to find the molar conductivity of MgI2. Mg out here we have Mg. There is only one Mg, so I don't need to multiply with 2. But in spite of that, we have 2 out, acetate CH2COO 2 out here. And then I2, we have only one I out here, NaI. So and we need I2. So in order to get I2, I multiply the entire NaI with 2 out here. So when I multiply with 2, I will have 2 Na as well as 2 I. So when I add these two together, I will have MgI2 as well as 2 Na and CH3COO 2 out here. So if I add these two together, if I join these two together again, I will have CH3COO Na. Since this is 2 and this is 2, I write here 2. So I don't need this one out here. So since I don't need this one out here, I'm going to subtract, and just similar to this one we have out here as well, CH3COO Na, but only 1 out here. So since this is 2, so I multiply with 2 out here, this one, and then this and this I can cancel together, and what is left? Only MgI2. Always remember, you're going to add 2 things and subtract 1, and out here you need to balance it. So now I'll write down the values. 18.78 plus 2 multiplied by 12.69 minus 2 multiplied by 9.10. So our answer shall be 25.96 cm square per mole. So now we shall try our next problem. Calculate degree of dissociation alpha of acetic acid if its molar conductivity is 39.05 Siemens centimeter square per mole, given ionic conductivity of H plus is 349.6 and ionic conductivity of CH3CO minus is 40.9. So I'll just write down the given. These are our given. So we are supposed to find molar conductivity of acetic acid. First we shall find the molar conductivity of acetic acid. So this is our acetic acid, CH3COOH. So in order to get these two, I need to add these two out here. If I add these two together, I will get this one. There are ionic conductivity of CH3COOH. So molar conductivity of any electrolytes is equal to the sum of the contribution of the ionic conductivity of both cation and anion. So ionic molar conductivity of CH3COOH is equal to you add these two together, you'll get 390.5 centimeter square per mole. So remember, we are supposed to calculate degree of dissociation. Now, what is the formula for degree of dissociation? Degree of dissociation is represented as alpha out here, C by naught. So out here, this is molar conductivity at infinite dilution, whereas molar conductivity of a solution at any concentration, this one, at any concentration, whereas out here molar conductivity at infinite dilution. So this you have out here 390.5, and this is given out here the equation at the beginning of the equation. It is 39.05. 39.05. So if you divide this one, you'll get 0.1. So in order to convert to percentage, you multiply with 100 and you'll get 10%. So this will be your degree of dissociation. Now we shall try our next problem. Calculate the molar conductivity of a solution of MgCl2 at infinite dilution, given that the molar ionic conductivity of Mg2 plus is 106.1 and Cl minus is 76.3. So you are supposed to calculate the molar conductivity of MgCl2. So first I will just write down the given. So here is our given. So you're supposed to calculate molar conductivity of MgCl2, given that the ionic conductivity of Mg2 plus is 106.1 and Cl minus is 76.3. MgCl2. So how can you get MgCl2? You add these two together, you'll get MgCl2. But remember, out here there is only one Cl. So you need to balance the reaction. So the Mg, out here we have Mg, so Mg2 plus now Cl2. Out here there is only one Cl, so I need to put here 2 in order to get 2 Cl. So here is your answer, 258.7 Siemens centimeter square per mole. You multiply with 2 and then add them together, you'll get the answer. So now we are left behind with our last question. Conductivity of 0.00241 molar acetic acid is 7.896 into 10 to the power minus 5 Siemens per centimeter. So this is your conductivity. So that is represented by kappa, and this becomes your concentration. Calculate its molar conductivity, and if molar conductivity at infinite dilution for acetic acid is 390.5 Siemens centimeter square per mole, what is its dissociation constant? So let's write the given first of all. So out here, if you look at the coefficient, you will see conductivity, that is represented by kappa out here. Conductivity of 0.00241. This becomes your concentration, that is molarity of acetic acid is so this is your concentration out here, 0.0241. So molar conductivity at any concentration is this one. So you're going to calculate molar conductivity. So that is represented by this at any concentration. So we're going to calculate this one first. And then molar conductivity at infinite dilution is given out here, and you're supposed to find dissociation constant K. So using all this given, we shall find dissociation constant K. So first, we shall find this one. In order to get dissociation constant, kappa into 1000 into m. So this becomes your molarity out here. Kappa is 7.896 into 10 to the power minus 5 divided into 1000 divided by 0.00241. So if you calculate this one, you shall have 7.896 into 10 to the power minus 2, 0.00241. If you calculate this one, you shall get degree of dissociation. Why we are finding all this? So in order to find degree of dissociation, you need this one as well. So we need to calculate this C by naught. So 32.76 divided by 390.5. So if you calculate this one, you shall have so this becomes your alpha. Now we shall find dissociation constant K. C alpha square 1 minus alpha. So this is the formula to find dissociation constant. So in order to find this one, we need alpha. So out here, in order to find alpha, again we need this one out here. So first we find this one, then we find alpha, and now we are using the value of alpha out here in order to find dissociation constant. So C is 0.00241 multiplied by 0.0839 whole thing square 1 minus 0.0839. This becomes our dissociation constant, 1.85 into 10 to the power minus 5. So this is our value for dissociation constant. So I hope you understand the problem. If you face any problem, please don't hesitate to ask me in the comment section. Thank you.